Okay, still with 7.1, the nth roots, and solving these um, radical functions here with some rationals and stuff. So when I'm doing this, I want to get all of this in parentheses all by itself. So I need to get rid of this number. So since it's a positive 12, I'm going to subtract 12 on both sides. And when I do that, that's gone. So I have a negative 3x plus 2 cubed. It's supposed to be a cubed there, and that equals 8. Now, this is negative, so I still don't have that in parentheses all by itself, so I need to get rid of that negative by dividing by a negative 1 on both sides. When I do that, the negatives are now gone. So now you have 3x plus 2, all that to the third, equals a negative 8. Okay. Since it is to the third, the opposite of something to the third is the cube root. So I take the cube root of both sides, which means those are gone. And all I have left is the 3x plus 2. But the cube root is three numbers that multiply together to give you negative 8. Well, that's negative 2 times negative 2 times negative 2 works. It says it's odd. There's only one answer that works, and that's negative 2. So really, here's what I end up with. I end up with 3x plus 2 equals negative 2. So to get x by itself, I would subtract by 2 on both sides, so they cancel out. So I have 3x equals negative 4. I would divide both sides by 3. They cross out so that I get x equals negative 4 thirds as my answer. Okay, and that's the last problem there. Once again, the keys here to keep in mind are when you have even roots, you get two answers. You get a plus and a minus. All right, you get two answers there. When you have odd roots, you only get one answer, and whatever that answer is, you only get one answer. Okay, so keep that in mind. You only get one answer to the problem. So other than that, I'm trying to think of some other little things for you to keep in mind when you're doing these problems. Um, but if you can simplify things, you do need to simplify them. And by that I mean, let's see if I can find one for you. What if I gave you the sixth root of 192? I know you're sitting there saying, well, some number 6 times, does that give you 192? No, it doesn't. But what I can do is I can split this up into 64 and 3. And that means I have the sixth root of 64 and the sixth root of 3. The reason why I can do that is this right here, the sixth root of 64, that is a number. And that number is a 2. That simplifies to a 2. So really your answer to that problem is 2 times the sixth root of 3. Okay, so sometimes you have to check to see if a number does go into this. So the best way I can see for you to find out an example like that is, let's take a look at that again. So you're sitting here going, okay, think backwards. Whenever you're trying to simplify, it has to be a whole number, right? So I would type in 2 to the 6th power. 2 to the 6th power. When I type that in on my calculator, 2 to the 6th power equals 64. So here's what you're going to do. That certainly doesn't give you 192, so let's try the next one. Let's just double check to see, does 3 to the 6th power give me 192? Nope, that gives me 729. It doesn't give it to me. So here's the point. The reason why I'm telling you this is, well, there isn't a number that works, a nice whole number. So I have to now see, can these divide into 192 nicely? Well, this one definitely can't. The reason is because 729 is bigger than 192. So I need to try this out. Can this number divide into 192 evenly? So I would take 192 divided by 64 in my calculator. And when I divide that on my calculator, right, when I divide 192 by 64, I got 3. So since I know that it goes into it evenly, that's how I know I can separate this into 64 and 3, because that's telling me that I know 64 that has a sixth root. So I need to simplify it if I can, and 64 does go into 192 three times. That's why I have a 3 over there. So 64 and a 3, and that simplifies to a 2. So you get two sixth roots of 3. So I hope that helps. And once again, you need to keep in mind if you can simplify these roots, then you need to do it. But thank you very much.